So for this problem, they want us to find the exact values of x and y. Now, we're going to assume that this is a right triangle. If it's a right triangle, you can use the Pythagorean Theorem and SOHCAHTOA. In this particular case, look at where your angle is sitting. Let's label our sides as opposite, adjacent, and hypotenuse. So we're going to remember our little acronym here, SOHCAHTOA. The SO is your sine, your CA is your cosine, your TOA is your tangent. First, let's go ahead and find our y value. I know that the sine of theta is opposite over hypotenuse. So the sine of 60 degrees is opposite over hypotenuse. So to solve that, we're going to need to cross multiply. So y would equal the sine of 60 times 26. Now, the sine of 60 is one that we know. You'll notice that the answer says exact values. The sine of 60 is the y value on the unit circle at 60. So this is square root of 3 over 2 times 26, which is 13 radical 3. Now let's go ahead and find x. We know that the cosine of theta is adjacent over hypotenuse. So the cosine of 60 degrees is adjacent over hypotenuse, x over 26. We're going to cross multiply the 26. So the cosine of 60 degrees times 26 equals x. The cosine of 60 is 1/2, so that's 1/2 times 26. So x is going to equal 13. So that's how you do that one. Let's go ahead and look at this one. It says that you're standing 45 meters from the base of a building. Okay, so here's our building, and apologize, I can't draw. Here's our building. We're standing 45 meters from it. We're going to assume our building forms a right angle to the ground. And it says you estimate the angle of elevation to the top of the 86th floor. The observatory is 82 degrees, so that would be this angle here when we take our head and look up to the top. Now that gets us to the 86th floor. Excuse me. Now, it says that round our answer to the nearest 10. The total height of the building is another 125 meters above that floor. What is the height of the building? So first, let's figure out what's the height up to the 86th floor. So that would be a tangent, because tangent is opposite over adjacent. So it would be the tangent of 82 is opposite over adjacent, and we're going to cross multiply by the adjacent. So 45 times the tangent of 82 equals x. And that gives us 320.2 meters. Now remember, the actual height of the building, it does go up on another 125 meters. So if we add 125 to that, our final answer would be 445.2 meters. So that's A. Now for part B, it says one of your friends is on the 86th floor. What is the distance between you and your friend? I'm going to label that a y. Now at this point, we know x is 445.2. You are welcome to calculate it multiple ways. One way, we can use now the Pythagorean Theorem. Since we know the adjacent and the hypotenuse, we could also use cosine. So there's multiple ways to do this part. I'm going to use the Pythagorean Theorem. We know if we use the Pythagorean Theorem that we'll call it a squared plus b squared. Our leg squared should equal our hypotenuse squared. And we get an answer of 323.3 meters. Let's take a look at this one. So this is going to use our Pythagorean and our SOHCAHTOA, but we are going to need to draw this on the xy plane. So take and draw your xy axis. Put the point -7, 2 on your xy axis. So if this was -7 and this were -2, there would be our point. We would connect that point to our origin. We would connect that point straight perpendicular to our x-axis so that we form a right triangle. Our right triangle, and then our inside of our right triangle is theta, which would be close to the origin. Here is -7, here is -2. Now your x or your y in your triangle might be positive or negative because it's somewhere on the coordinate plane. Your hypotenuse is always just represented by a length. So if we do the, find the length of the hypotenuse, -7 squared is 49, -2 squared is 4, 49 plus 4 is 53, so this would be the square root of 53. Okay, so let's think about what our sides are. Our opposite is -2. Our -7 is our adjacent. It will always work like that. Your x is going to be your adjacent, your y is going to be your opposite. And then, of course, our hypotenuse is that length from the point to the origin. Now remember, we're going to do sine, cosine, and tangent. This is opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. Now when we're dealing with these values, technically this is going to be y over r, this is going to be x over r, and this is going to be y over x. Okay? Now they wanted to find 6 trig functions, so our cosine, our sine's reciprocal is the cosecant, which just flip over the opposite over the hypotenuse or the y over the r. Our flip of our cosine is the secant, which is r over x, and the flip of our tangent is our cotangent, which is x over y. So now we're ready. So our sine of theta, now see what they used, their language here. They used the words exact values, so please note that. You should be doing the exact values, which means no calculator. You just set them up, reduce them down, and stop. So the sine is going to be -2 over the square root of 53. When rationalized, that's -2 radical 53 over 53. The cosine of theta is -7 over the square root of 53, which is -7 radical 53 over 53. And the tangent of theta is opposite over adjacent, or y over x, which is 2/7. Now let's go ahead and do the 3 reciprocals. Our cosecant we're just going to take the reciprocal of the sine. To me, I think that this version right here will be the easiest to take the reciprocal of, because we can just take that radical and flip it to the top. So that's going to be radical 53 over negative 2. Let's just throw the negative in front. And then the secant, again, I'm going to flip this first version here. So it's going to be negative radical 53 over 7. And then finally our tangent, I'm going to flip over this 2 over 7 because it's already reduced and make it 7 over 2. So those are your exact values of the 6 trig functions. Let's look at problem number 10. So there's multiple ways to do this. You can do it very similar to what we did in the last problem, but I'll show you a mixture of ways. So first off, they tell us that we want to find the values of the 6 trig functions given that the cosine is 4/5 and the tangent is negative. Now, let's think about our quadrants for a minute. The tangent is negative here or here. We want the one where our cosine is positive. Well, the cosine is our x value. The cosine is positive here. So I'm going to draw my triangle in the third quadrant. Now let's think about what we know. If the cosine is 4/5, this is our adjacent, this is our hypotenuse. So let's put those on there. We can use the Pythagorean Theorem to find our adjacent side, and our adjacent side is 3. But remember, it's in that fourth quadrant, so we would need a negative in front. And now we're ready. The sine is opposite over adjacent. The cosine they already gave us. The tangent is opposite over adjacent. The cosecant is the reciprocal of the sine, so just flip that one over. The secant is the reciprocal of the cosine, flip that over. And the cotangent is the reciprocal of the tangent, so flip that over. And those are the exact 6 trig functions. Now, you could have used some of the rules we know before, like sine squared plus cosine squared equals 1. You can use that to find the sine and go from there. Drawing is very easy.